So far, when you've been using the Database Navigator, you would have noticed a variety of different types of database objects, and you've probably wondered what those were all about. At this point, you know all about tables. We spent most of this course on querying tables, and in the last few chapters, we looked at how to create tables, and then insert, update, and delete data from those tables. So you're a tables expert by now. In this and the next few videos, you're going to get a deeper understanding of views, materialized views, functions, and aggregate functions. For this video, let's just start with views. A view is a database object that you create. It lives inside the schema, just like a table does. And a view is very much like a table. You can think of it like a virtual table. It doesn't really exist on disk, like a table does. Instead, a view is defined by a query, where the query is run each time you access the view. Why would you do this? One big reason is convenience. You might have noticed that you often end up repeating yourself several times when writing queries. For example, there are some common joins that you just end up doing over and over again. You can encapsulate that within a view, and then you, or any other database user, can use that view over and over again, saving yourself time, hiding complexity, and making your queries a lot simpler. But it's important to remember that a view never stores any data. You should think of it like a virtual table. So in this video, we're going to be looking at creating views, and in the next video, I'll show you something called materialized views, which actually do support a form of caching. Views are part of ANSI SQL, while materialized views are specific to Postgres. One thing that's a little bit annoying about our current database design is an address is split over multiple different tables. Let's have a look at the relationship diagram. You can see that a full address, for example for a customer or for a staff member, is split over 3 different tables: the address table, the city table, and the country table. This means that if you're writing a query and you want to display the full address, you would always have to perform all those joins manually as part of your query. So let's go ahead now then and create a view that represents the full address. Once we've created this view, we can then use it anytime we want in future queries, or any other database user can use it as well. We start out a view definition by writing create view. We give the view a name. I like to preface all my views with VW. And what we provide now is the definition for this view. That is, the query that's going to be run every time you access the view. So I'm going to write a query that just returns the key details for an address. So I'll join from the address table onto the city table, and now I'll join the country table. And the key details that I'm going to return are the address ID, the actual address, the district, the city name, and the country name. Before I go ahead and try to create this view, I'm actually just going to run the query on its own to ensure it's exactly what I want. I can do that by just selecting the query itself and running that. So there's an address ID, an address, the district, the city, and the country. So that's what I wanted, that's great. So now I'll run this entire statement to create the actual view. It's important to note that creating the view didn't run the query. It simply saved this view definition for later use. And we should now be able to see this view in our database navigator. Refresh the views list. We have one view, VW_address_details. Good. You can now, going forward, just treat this view like a regular table in your database. For example, you can select from it, and that returns all the rows from this virtual table. And you can write a query to join onto it as well. You can just treat it like a regular table in your database. For example, let's now write a query where we return the count of customers from each of the different countries. So we start by selecting every customer, and we'll inner join onto our view. We'll join on the address ID column. We'll group all those customers by the country they're from. And so we'll select the country itself in our results and the count. And then we'll order by that count descending. So this query should return us a count of the number of customers from each country, showing the most popular countries first. And I just need to fix up one error, which is to use the right name for the view. Okay, let's run this query now. So we can see from the results, most of our customers are from India, then China, then United States, and so on. So while previously we would have had to write all those annoying joins, now whenever we want to get a full address, we can simply use this view that we've created. And so can anyone else who uses the database. They can benefit from all the useful views that we've created, and we can save them time and effort when they're writing queries. Views can be useful for more than just convenience. Sometimes you might want to control the details that certain database users can see. For example, let's say that there was sensitive information inside the customers table, and I didn't want all of the different database users to be able to view that information. What I could do as a database administrator is not grant the select permissions for that table for different database users. Instead, I could create a view which shows only the non-sensitive information and grant those database users access to that. So through views, you can manage what data is visible. You can also update the data in tables through views. So for example, you could write an insert or update statement against the VW address details view that I've created. There are quite a few rules and caveats to doing so though. The query that defines the view has to adhere to certain rules or it won't work. I won't be going into that here though. If you're interested more in the topic of inserting and updating data in tables through views, I'll add a link in the video description for you to follow. Finally, I'll quickly point out that if you want to delete the view, you can simply type drop view and give the view name. And that deletes our view from the database.